Hey guys, so we have some new pieces of information here. This is for worksheet 65A. It's supposed to be typed in right here, but apparently it's not. So this is for worksheet, I'll put it over here, worksheet 65A. So we're going to start working with what's called our first and second derivative tests. I just wanted to go over a few things, and then we'll do number one on the worksheet, and then you guys have 2, 3, and 4 to kind of finish. So if we if we look at this, let's just kind of remember a few things, and you can stop the video now and write this down. To find critical points, we're just going to take f of x, and we're going to set it equal to 0. That's all we're going to do. Okay? If we're going to find maximum and minimums, or these are also called extrema. So extrema, that's an M. Extrema, let me erase that because that's just horrible. Extrema, and that's still horrible. Let's do it one more time. We're going to call this extrema, and we're going to set f prime of x equal to 0. So remember that the reason we do this is because that is a horizontal tangent line. And so what we're trying to do is, let's just say we have this crazy graph that goes like this, right? We're finding out where everything is flat and it turns. So when we set f prime of x equal to 0, we're finding all these spots that it turns, okay? And now our points of inflection, which these guys are going to be new to us, this one and our concave up and our concave down, they're going to have to do with the second derivative. So if the second derivative equal to 0, there's a potential inflection point. So what an inflection point is something that looks like this on the original graph. It goes like that. So an inflection point is where we have a horizontal tangent line, but it changes from a concave down. See how this has got a curve down here, to a concave up piece. And so that is an inflection point here, where it would go from concave down to concave down. You're pretty much looking at the idea of a maximum or minimum. So it's a potential inflection point, but it's not necessarily an inflection point. You got to have a sign change when it comes to that second derivative. So concave up and concave down. If f prime is greater than 0, so if f double prime is greater than 0, it's concave up. If f double prime is less than 0, it's concave down. I attached some charts on the weekly playlist. I would print those out or copy them down so you can use them. That kind of helps you kind of figure some things out. So let's tackle this next one here. So we're gonna tackle the first one, and the first one they give us f of x. F of x is equal to x squared plus 2x plus 1. So let's just take that and factor it into pieces. So we're going to get x plus 1, and we're going to get x plus 1. All right, so that's f of x. Let's take f prime of x and put that down. So I'm going to take f prime of x. So I'm going to take the derivative of this, which is going to give me 2x plus 2. And then I'm going to do f double prime of x, which just means I'm going to take the derivative of the first derivative, which is going to give us a value of 2. So let's just kind of use our pieces of information that we just had prior to this. So I'm going to find my critical points here. So this is my critical points. I'm going to change colors here just so we can have these on a graph. So I'm going to set this equal to 0. So I get x plus 1 equals 0. I get x equals -1. And I get 2 of those, so therefore this thing's going to bounce at this critical x value. So this is my x-intercept. So we have one critical value. So then here's my possible max or mins, right? So let's go back up here and let's tackle this. And this is either my maximum, my maximum or my minimum, not sure. And what we're going to say is 2x plus 2 equals 0. Because I'm going to do f prime of x is equal to a horizontal tangent line of 0. That's where that comes from. So when we look at this, we're going to get 2x equals -2 and x equals -1, right? So then on this point here, I don't have any, I don't have the ability. So if I set f double prime equal to 0, I don't have, there's no potential inflection points. So I don't have to worry about inflection points. And I know right now that since this is always going to be positive, f double prime of 2x is always greater than 0, right? It's always greater than 0. It says it right here. That 2 is never going to change. So that's going to be greater than 0. So if we go over here and we look at this, and let me see if I can find my cursor here. Where's my cursor? There it is. So let's go here. Let's change a little bit of color here. Let's do green, just because we can. And we set a graph up right here. That'll work. And let's do another one. That one stay? It did. And we got our graph. All right, cool. So if we look at this, we have a graph right here, and we have our yellow x-intercept, which is at -1. So we're going to go over here to -1, and we're going to put that right there. Okay, so then we know that it's a maximum or minimum, but we don't know which one yet because we've still got to figure out what point that's at. So if I want to find my x value here, so I'm going to go back and I'm going to change this color here back to, I think it was that color. It might have been that one. I don't know, something in there. So if we take this one, and I know at x equals -1, I have a maximum or minimum, I can take f of -1. So I'm going to plug it back into the original, and I'm going to get -1 squared plus 2 times -1 plus 1. So this is going to be +1. This is going to be +1. So +1 plus 1 is 2 minus 2. So at f of -1, it's 0. So at this particular point right here, when I plug in -1, I get 0. So right there is either going to be my maximum or minimum. So that comes to tell us that if we're looking at this, f prime is always positive. So that means this thing is going to be concave up. What do we mean by concave up? It's cupped up like that. So our graph is going to look something like that. Much better next time. So that's the idea. And so if we really look at this, if we look at this piece here, if I set it equal to 0, I've got my x-intercept. If I set my f prime equal to 0, I'm looking for maximum or minimums. And if I plug my if I plug my x minus 1 in, x equals negative 1, so my main points of my f prime, if I plug them in, I can plot them. And so there's my max or min. What really tells us what's going on is the fact that since f double prime of x is greater than 0, it's a concave up. So it's going to look like a cup. So then, therefore, my graph looks like this. And if you plug this into your calculator, your graph will look exactly like this. So, steps. Set that one equal, set f of x equal to 0 and find your critical values. Set f prime of x equal to 0 and find your maximums or minimums or your horizontal tangent points, which I didn't draw in here. But if we went to let's do our horizontal tangents in the rainbow color again. If we drew that across, that's where this is right here. That equals 0 is that rainbow line right there. And then if we set f prime equal to 2, then we end up with a positive, always a positive f double prime or a second derivative. And that tells us by that chart that it's concave up. So those are your basic steps. Now we can look at it. Once we graph it, we can also look at it this way. Let me go. And then don't forget, let me come back over here. I got to actually do it on the right thing. Don't forget, and we'll do this one in, let's find out what more colors are. Those aren't that much fun. So let's just do it in gray right here. Okay, so we also know that it is decreasing from this side here down to the critical point. So we know from negative infinity to -1, it is decreasing, and it's also increasing from -1 to positive infinity. That's what the graph's doing, okay? And so that's kind of our idea for the intervals. So if we look at the concave up interval, so the concave up, it's concave up. Let's do that from negative infinity to positive infinity. And let's see anything else. There's no points of inflection because we couldn't test any. It's never concave down. This one's never concave down. Your relative maximums and your relative minimums would be your points here. It doesn't have a maximum. It only has a minimum. But that's kind of how we're going to introduce using the derivatives, and then we'll kind of keep working with them. Other than that, work through the next two using these same steps, and we shall see you soon.